Welcome to Saxon Math Course 3, Lesson 112, Starred Problems. Now, Lesson 112 discussed the ratios of the side lengths of right triangles. So we're going to see a couple of problems like that in our starred problems, but we're starting off with a look back at the lesson that we ended the week on last week, which is the surface area and volume of a sphere. Now, question number 2 is our first starred problem. It says a classroom globe of Earth has a diameter of 12 inches. And then it says, A, on the globe, how many inches long is the equator to the nearest inch? Now, the equator is the line which goes around the center of the Earth at its widest point. Now, that's effectively the circumference of the circle in the middle of the globe, which would have the same diameter as the globe does. Now, the diameter of the globe is 12, and the formula for circumference is diameter times pi. So we're going to do 12 times 3.14. The reason we're not just saying 12 pi is because it says to the nearest inch, and if we're going to estimate, we have to find an exact answer first. Now, 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. We'll put a 0 as we're moving to the tens place, and then we have 4, 1, and 3. As we add those out, we're going to get 8, 6, 7, 3. And then if we're rounding to the nearest inch, we need to know that there are 2 digits to the right of the decimal place. We're going to round up to about 38 inches. Then we're asked to find the surface area of the sphere. Now, the surface area is equal to 4 times the radius squared times pi. Now, the radius will be half of the diameter, so it's not 12, it's 6. Now, that means we're going to have 4 times 6 squared, which is 36, times 3.14. And if we multiply 4 times 36, 4 times 36 over on the side, 36 times 4. 4 times 6 is 24. 4 times 30 is 120. So we're going to have 144. And if we multiply 144 by 3.14, we're going to get 452.2, which is about 452. Now, question 3 says, which is the best estimate for the volume of the sphere in problem 2? Now, volume is 4/3 of pi times r to the power of 3. Now, I'm going to do a very rough estimation here, and what I'm going to do is I'm actually going to estimate pi to be 3, which is 3 is much smaller than pi. Pi is 3.14, but it allows us to do this elimination right here. Now, 4 times 6 to the power of 3. 6 to the power of 3 is 216. If we multiply 4 by 216, we get 864. Now, one thing to note is I estimated 3.14 down to 3. That means my real answer should be above 864. It should be close to this, but it should be bigger. Now, if I look at A, 450, that's smaller. B, 900, that's very close, and that's probably my answer. 1,200, it's further away than 900, so it's not a better answer than 900. And D is 7,000, further away from 900, so it's not the better answer. So we're going to go with B. Question 4 gives us a picture of a roof and the shapes which make up the roof. Now, in the book, it doesn't have this 11 here. It has it in the writing. It says that the line that connects the base of the roof to the top is 11 long. So then it asks us to find the area of the roof. So the area of the roof is going to be the area of this shape, and then there's 2 of them, so we're going to do times 2, plus the area of the triangular shape times 2. Now, a cool thing to note is that both in the area of a trapezoid and in a triangle, we divide by 2. So if we take this half and this 2 and we get rid of them, and this 2 and this divide by 2, and we cancel those out as well, we can get 20 plus 40 is 60 times 11 plus 20 times 11. Now, 60 times 11 will be 660, and 20 times 11 will be 220, which means that the total area will be 880. Now, our units here are feet, so it's going to be in feet squared. Now, question number 5 is our next starred problem. It says convert 0.81 repeating into a reduced fraction. So we're going to set up the fraction f equals 0.81 repeating, and 100 times the fraction equals 81.81 repeating. Because 100 times 0.81 repeating, you just move the decimal over twice. Now, if we subtract the original equation, 100 minus 1 is 99. So 99f will equal 81. Now, if I divide both sides by 99, I'll get 81 over 99. And I can reduce that by dividing both of these by 9. 81 divided by 9 is 9, and 99 divided by 9 is 11. Now, these are both numbers which cannot be reduced any further. 11 is a prime number, so even though 9 can be divided by 3, 11 cannot be. So 9/11ths is our final reduced fraction. The next starred problem is problem number 7, and problem number 7 is the homework problem that's based off the lesson we just learned. So part A says find the ratio of the length of the side opposite angle B to the length of the hypotenuse. Now if we look at angle B, the opposite side is angle AC. The hypotenuse across from angle C is AB. Now, the opposite is 1, the hypotenuse is 2, so if I put the opposite over the hypotenuse, I'll get 1/2, and that'll be my ratio. We're then asked to find what is the ratio of the side adjacent to angle B and the hypotenuse. Well, the adjacent side, if we know that this was the opposite, then this is the hypotenuse. This last one, BC, has to be my adjacent for angle B. The hypotenuse is still angle AB because regardless of what angle we look at, the hypotenuse of the triangle never changes. Now, the adjacent BC is the square root of 3. The hypotenuse is 2. Now, if I put the ratio of the adjacent to the hypotenuse, that means adjacent over hypotenuse. So we're going to have the square root of 3 over 2. And that'll be that ratio. Now, question C changes the angle we're looking at to angle A. The hypotenuse won't change, but the side that was the opposite will now be the adjacent, and the side which was the adjacent is now the opposite. So we're asked to find the ratio of the opposite to the adjacent, the opposite side being BC, the adjacent side being AC. BC is the square root of 3, AC is 1, so we'll put the square root of 3 over 1, which can reduce to just the square root of 3. And that's question number 7. Question number 8 is a 3-part question. Part A says to find the volume of the smaller cone, right here, in terms of pi. Now the volume of a cone is 1/3 times the height times the radius squared times pi. Our 3 dimensions being height, radius, and radius. Now, 1/3 of the height, which is 3, is just 1, and 1 squared is 1. So I'm going to have 1 times 1 times 1 times pi. So I'm just going to have pi inches to the power of 3, pi cubic inches. Now, part B asks us to find the ratio of the surface areas. Now, the ratio of the surface areas is the ratio of the scale factor squared. So the scale factor, if we put the small one over the large one, I could have 1 over 3, which will be reduced already. And I'll square 1/3. 1 times 1 is 1. 3 times 3 is 9. So the ratio of the surface areas is 1/9. Part C asks me to find the ratio of the volumes. The scale factor doesn't change, but instead of squaring it for volume, I raise it to a power of 3 because a volume is a three-dimensional unit. 1 times 1 times 1 will always be 1, and 3 times 3 is 9, times 3 again is 27. And that's question 8. Now, our penultimate starred problem, which means second to last, is starred problem number 9. Now, starred problem number 9 asks us to graph to solve. Now, we have the equations x plus y equals 1. Now, if I replace the x with a 0, 0 plus y equals 1, that just is y equals 1. If I replace y with a 0, x plus 0 equals 1, well, that means x is 1. So I'm going to have the points 0, 1, and 1, 0 right here. I'm going to get a straight edge, and I'm going to connect them. And then for this next problem, for this next line, we're going to have negative 5x plus 10y equals 20. If we replace y with 0, 10 times 0 is 0, so we're going to have negative 5x equals 20. If we divide both sides by negative 5, x will equal negative 4. If we replace x with 0, we'll have 10y equals 20. If we divide both sides by 10, y will equal 2. So we'll have 2 and negative 4, which means we'll have the point out here at 1, 2, 3, negative 4, and 0, 2. Oh, I'm sorry. This is negative 20 in the problem. Now, if we do change this to a negative 20, we're going to have a positive 4 here and a negative 2, which is just a small mistake in the problem. So we're going to have negative 2 right here and positive 4. So a slightly different set of points. Now, if you ever get to a point where you're graphing a set of equations and you notice that you're not going to be graphing through a set of intercepts, a actual point where they're going to cross, then you should go back and check your work because you probably missed something in the problem like I just did. Now, when you go through and you connect these dots, now you have a line which creates an intersection here at the point 2, negative 1. A much better intersection than this random space over here would have been that's not quite on the lines. Now, that means my answer is 2, negative 1. Now it's important to note this is my x value, this is my y value. If I plug these back into the equation, 2 plus negative 1 is 1, and if I plug this back in, negative 5 times 2 is negative 10, negative 1 times 10 is negative 10, negative 10 and negative 10 make negative 20. So it works in both equations. Our last starred problem is question 23, which asks us to graph negative 0.8 x squared. Now, if we are going to graph that, I'm going to make this a little bit expanded because I know that as I'm going through and graphing it, it's going to be a decimal. So negative 2 times negative 2 is positive 4. 4 times 8 is 32. So 4 times 0.8 is going to be 3.2. But it's negative, so our answer is negative. Because a negative times a positive is a negative. So we're going to have negative 3.2 with negative 1 times negative 1 is 1, and 1 times negative 0.8 is negative 0.8. 0 squared is 0, and 0 times anything is 0. Now, it's important to note that if I had 2 squared or 1 squared, I would still get the same answer for the second line. So, since I'm going to get the same answer in this second line, I can just copy my answers down right here. Now, I have the point 0, 0. I have the point negative 1, negative 0.8, and 1, 0.8. And I have the point 2, negative 2, 3.2, and 2, 3.2. Now, remember, these will not be a straight line, but you're going to want to try and create a gradual curve as you're going through. And it slowly gets steeper as time goes along. Sort of like that. And you're going to try and do your best to create the exact opposite line on the other side. And that is the final start problem. That's question 23 for lesson 112. Stay safe, stay inside, and wash your hands.